Today is the 12th of August, and what we have on this second video, this is the second part of that first video that we sent last week. We've taken Neeltran ISOVLCL2X with the different modifications. We took a board just the way that we sent it out to Neeltran, and these are the modifications that we made. We removed that 14, the 301K. We removed the C1 capacitor, 3.74K. We removed the jumper from J14 to J22. This is because the isolation U2 will be installed. We also removed resistor RX, which was on U2, and we removed the sockets. And we also removed one of the jumpers associated to RX1, which connected U2 pin 36 to U2 pin 19. C1 and C4 are not installed. This was one of the questions that we had with George. We didn't have to install them. Now we installed U2. There's the isolation amplifier. We installed for R15 49.9, and for C3, what Tony did is on CR2, he installed the 5.6 just because CR2 is just like a resistor. We don't have to hairpin that. This is for the 10-to-1 attenuation, and there is that jumper between pin 3 to pin 6. Basically, we've had R15 CR2, that's a 10-to-1. This is bypassed U3 pin 3 to 6, and now U2 is there reestablished. No RX1, no jumpers, and we're going to show that if we bring in a 1 volt here, when the current feedback is 10 volts, the board will behave. Okay, so we have now our board. Again, we're using 6100 6-pulse full wave rectifier, and we have our AC input. We don't have any output right now because our commands, our voltage and limit commands are at 0, and here we're measuring the voltage feedback, the current feedback, both sides for 10 volts. We're looking at SIG height, the output of the regulator, and here we have our traveling multimeter. Alright, so I'm going to ask Tony to go ahead and start bringing in the voltage and current. By the way, we noticed that the way it is now, two things. We don't have a current limit, a current trip, an overcurrent trip, or a voltage trip. And one of the things that is different from Neeltran Diversified is that at this point we are keeping 1, 3, and 4 all common on the isolated part of the circuit. Again, we remove the jumper, and the only difference is here that we're not using pin 2 exclusively for the voltage and 3 and 4 exclusively for the current. So go ahead, Tony. So
put the voltage in.
What you're going to do is bring in all the voltage?
Yeah.
So you're then okay. And again, you don't have any output because the current is still at 0. So you're going to bring in the current, and now we're starting to change the delay angle. We notice that CKI now is changing accordingly. And if you bring it at full on, Tony, go ahead. We have 243 going in on the AC. The DC output is 321. The voltage feedback and the current feedback now at full on are 10 volts and 10 volts. CKI is the maximum, 6 volts, 6.16. And I'm going to ask Tony to go to test point 1. Is that test point 1, Tony?
TP1.
Again, keeping in mind that if we bring in 1 volt of feedback, the value of tip in 2 is 2 volts. And then let's go to test point 4 for the voltage. And there again, this is twice, just like in the previous video, TP4, the voltage feedback is 4 volts. Now, and again, here at this point, we can start checking the thresholds, the current threshold, the voltage threshold, to get an overcurrent trip or an over voltage trip. And that's something that I've already done on the first video, so we won't do it. The last thing that I'm going to ask Tony to do is to take a meter, go to the, now we need to go to the isolated part of it, Tony.
Okay.
And I need you to go to J1 position 4. and go to J2 position 1, which it's the jumper on U3 position 6. So again, we're going from J1 position 4, that's a negative, and you're going to the jumper of U3, because that gets connected to the input of U1. Alright, so you have, there's the jumper, and you're already connected with respect to pin 1.
Pin
of
4.
Pin 1.
Pin 4 is ground, right?
I'm sorry, pin 4. Where's your pin 4?
Okay.
Right there. Alright, that's your meter. Alright, and we have 1 volt. So again, now the board is happy because we're bringing in 1 volt of DC feedback when the actual current feedback is 10. So or divide by 10 is good, or isolation is working good. So this is the end of this video.